So I don't hear you at all. You disable your microphone and then try and enable it. Do you have a microphone connected, Karen? So I don't hear you, so I think you'd better type in the microphone may not be enabled on your machine or may not be connected. So I see we have, okay, now we're starting to get questions. Great. So first, let's do Luigi's question. You don't understand how the force healing function works in quasi-static simulations. So let's go over that. I'm going to switch here to the whiteboard for that question so I can draw. Actually, let's go to the slides. I'm going to go back to slip weakening friction here. And so in the essence of the healing is at what point, if I start accumulating slip and I exceed my value of D0, at what point do I want the coefficient of friction ever to return to its static value? In a quasi-static simulation, usually we're thinking of an earthquake occurring in one time step. Because we're using time steps of, say, 5 years or 10 years, and so we want all the slip associated with an earthquake to occur in one time step. And then when after that earthquake occurs, we want the fault to heal so that we get stick slip behavior and the static coefficient of friction. And so we get back to the static coefficient of friction rather than the dynamic coefficient of friction. If we remain at the dynamic coefficient of friction, any increase in the loading is going to generate additional slip. And so in a quasi-static simulation, when I use this force healing to be true, that means once at the end of a time step, I'm going to reset my slip value here to 0. And so this is not this is sort of the accumulated slip relative to when I had a static coefficient of friction of 0. And so I have actually a state variable within my slip weakening fault implementation to at the end of each time step, I reset that cumulative slip to 0. So that then I'm going to develop this weakening at each time step if the fault slips. In a dynamic simulation, I want this dynamic weakening to occur over many time steps. Otherwise, I'm not going to have a robust numerical solution if I have it drop down from static to dynamic in one time step. And I want it to stay at that dynamic level until essentially the velocity or slip rate goes to 0. And that's just the differences between a quasi-static and dynamic simulation with the slip weakening friction. And so in most cases, if I draw in here, in a dynamic simulation, I'm going to end up with, I'm going to start out here at my coefficient of friction, static coefficient of friction, and then I'm going to have a time steps as I go down and follow my, and resolve this weakening over multiple time steps. I'm going to come out here, and I'm going to stay down here over multiple time steps. And then eventually, my fault's going to stop sliding. And it's at that point that I would then want to reset back to my static coefficient of friction. In the case of a quasi-static simulation, basically in one time step, I want to follow this down the curve, come out here to my whatever value of slip I have, and then at the end of that time step, I want to lock the fault back up. and so I go back up to my static coefficient of friction. In order to do that, I have to play around with what this value of D is and reset it to 0 to get back to my static coefficient of friction. So we answered that question. Robbie asked, in pair view, is there a way to insert coastlines? So in pair view reads, you can put in your information in VTK files. And so you can do a Google search for the VTK file format, or you can just look at our file format. And basically, you have to take if you're getting your coastlines from, say, something like what's embedded within provided with GMT, you need to extract those into ASCII XY files, and then add them, convert them into a VTK file format. You can do that either through a shell script or a Python script. Probably a shell script is easier. Or the alternative is to take in your sort of pilot output and use the HDF5 and massage into something that you could bring into GMT for the ground surface like a regular grid. So you could using the HDF5, you could dump out your values on, let's say, the ground surface and use the XYZ to GRD command to put it into a form similar to GMT. So you can either, somewhere in my, on my computer I have some scripts that Charles developed to convert coastlines for New Zealand into VTK. I don't know where he's getting his coastline information from. It may not be coming directly from GMT. If someone wants to go ahead and write that script, we'd be happy to post it on the Pilot Wiki so that it's available for everyone. So we have another question. Okay, no question, just raising my hand earlier. So Yang Zhang has a question about post-seismic after-slip control by friction. So we really didn't cover that in any of the examples today. That is step 04 in the 2D subduction zone example. And so in that case, we actually we use the output from step 03, or I guess it was the coseismic slip. In any case, what we do is we take the output from the coseismic slip, the coseismic slip simulation that gives us a traction perturbation on the fault. We combine that in the step 04 in the 2D subduction zone with information about, say, our overburden pressure. And so we take some background tractions, combine that with the traction perturbation, and then solve for the after slip that is imposed. I think we're using static friction in that case to compute the after slip. It takes a long time to converge because it's a 2D with a through-going fault, but it does converge. It also depends on our coseismic slip distribution was highly irregular, so we get some stress concentrations, and it doesn't look necessarily like what you'd expect from, say, just a smooth slip distribution with after slip down, just a down dip. We're getting after slip at other regions of the fault due to the initial conditions we were assuming. But 2D subduction, step 04, it's written up in the manual, and so you can go and walk through that. And if you have questions, please feel free to send an email to CIG-short. Any other questions for our last 5 minutes or so in this session? And as soon as this session is over, I'll type in answers to your questions, and those will show up on the Q&A panel for you, and then they'll get posted in the log. So if you're, for example, where is this step 4 problem, I'll give you the directory on where that is. Any other questions? Okay, so it looks like we got another question here. COMSOL for multiphysics. Yes, we're aware of COMSOL. COMSOL gives you, I think it was originally developed for as a sort of in conjunction with a piece feeding into MATLAB. So Matt, if you want to see the questions down in the Q&A pod, make sure you click on the left icon, which is the person with the rectangle, and then within the menu you hit the show open questions. So the questions about COMSOL for multiphysics, it has some sophisticated tools. It doesn't have, in terms of being able to create a mesh that is tailored to sort of not geophysical problems with complicated surfaces. It's not sort of as geared towards, say, what I would say realistic geometry. And as Matt points out, the solvers are not optimal, and so it does not run in parallel, that I believe. And so in terms of being able to develop robust simulations and get good parallel performance, assuming it even had parallel performance, you're not going to get the same type of performance that you get with Pilot. I believe COMSOL, is sort of a black box. You need to dictate the physics, and so you would have to implement things like your bulk constitutive properties. It may have some cases. I don't know if they have things like generalized Maxwell or Drucker-Prager models. They may have Drucker-Prager because those are pretty common in solid mechanics. They probably don't have rate and state friction. And how well do they resolve the rate and state friction deformation and sort of all the things that we've done to make our solvers robust with rate and state. They probably don't include, I highly doubt that they would include. So that's coming back to sort of this solver issue and having things sort of tuned for the type of problems. In the past, I know it was difficult. You couldn't really see what was going on underneath sort of the black box of COMSOL, and even sort of getting out all the information that we can extract from Pilot in terms of values, the solution at points, the state variables, knowing exactly where those state variables are coming from, being able to specify, being able to do parallel output, BTK versus HDF5, and so forth. So Pilot, open source, flexible, good documentation, a lot of physics are already implemented. So sessions available on the web. So the only thing that will disappear is this meeting room and the URL for this. The meeting room will be closed at the end of today, and there's a notice that Adobe Connect is doing maintenance tonight. So probably by 4 o'clock this afternoon, this meeting room will be closed. So that's why we've created the Q&A log that's posted on the website. So all of the questions and answers to those questions that we've typed in will be available on our webpage. Every single modeling tutorial and sort of CIG workshop that's ever been held, all the information that remains on the web. So as long as geodynamics.org website is accessible, I expect it'll have the content. The streaming movies are still available. They will remain available as long as I think UC Davis has an Adobe Connect account. We'll be creating QuickTime versions that will be stored locally. Next week we'll take the streaming versions, cut them up so that they're, instead of having a 2-hour-long movie, we'll break it up into sort of manageable pieces by topic, and then we'll post those as well as on the website, so we have access to all of the sessions as recorded. All of the slides will be accessible. The pile of examples, you have the tarball, you download them. So everything should be downloadable to your computer in terms of the content of the website, and it will hopefully remain on the web for many years to come. Any other questions before we wrap up this session? So couple final words. The session this afternoon in 2 hours will be on running Pilot in parallel. That won't be really looking much at the details of the problems we're running. We'll be looking at how do you run Pilot on your laptop or desktop in parallel to take advantage of the multiple cores that are likely there, as well as running on a cluster. What's the difference between running on a cluster? What do you need to be aware of? And another comment I have is that we would really appreciate getting feedback on these tutorials, so please complete the post-workshop survey, and the sooner, the fresher of what worked and what didn't work and what you want to see, the better, and we'll start sending out emails reminding you to complete that at the end of the session later this afternoon. But I'm doing it here verbally, just as a reminder to complete that post-workshop survey. So with that, one final call for questions.